Nyiga next. Nyiga next. Singa ne bagayi basobola okuleetayo amatooke gundi nga 2 noonya ne kwali webadde ogambye kale kwemmere eyo nne nate emmere yalinnya
Excuse me, teacher.
Yes.
Am I supposed to copy this?
And wanted to copy, I can send them to you if you want them.
Okay.
But we are guys. Did you enter direct?
No. I used the math ID and pin code.
But I don't remember accepting you, but I saw you already entered. But it's okay. So I'm finalizing the review on circles. I wanted people to help me with some numbers. I couldn't trace them very fast. Circles touching the line. This is the line, the circle. It has its center GF. It has its radius, and the line is touching the circle. This line is y is equal to mx plus c. And the circle is x squared plus y squared minus 2g minus 2gx minus 2fy plus c equal to 0. Then you have to solve these two simultaneously by getting this y and substitute it here. Also get this y and substitute it there. There you will design an equation in x so that you design a quadratic in x. It gives one repeated point, then the circle touches the line. If you get a complex number, get complex roots, then it is impossible for the circle to touch the line. Then if you get two values of x different, then the line crosses the circle. It will be in this form. To give you a point here, another point there. That's how the 2 points will come about. So when you solve simultaneously this equation of the line and the equation of the circle, and you get 2 values of x and y, then that would mean you have got 2 values of what? Values of x. Hence the circle is being cut or intercepted, or the line is a chord which cuts the circle. The other definition I want to talk about is the perpendicular distance of a point to the circle, whereby you have a circle of this nature, and there is a point here, P, which is xy. You have your center there, and you have your radius there. But if I draw a tangent through P, this tangent can touch the circle. Like this. Then I draw a line from the center to the point P. Then this tangent to the circle can be drawn back to the center to give this as the radius, then this one as a perpendicular distance. So if you're looking for the distance from the point to the circle, or from the point to the center, then you can get the distance CP, and perhaps you can look for the distance X, whereby CP can be capital D. Then X can be small x. So CP would be equal to R squared plus X squared under the square root. So you can find the distance of a point to the circle. Another condition I need to talk about is circles in contact. If I have a circle touching another circle, just touching, with this one having center 2, this one having center 1, then they just touch. Then you solve the two circles simultaneously by having x squared plus y squared minus 2g1 x minus 2f1 y plus c1 is 0. Then the second one can have x squared plus y squared minus 2g2 x minus 2f2 y plus c2 is 0. Then you solve simultaneously by elimination. You subtract them. When you subtract the two equations, you can eliminate x squared with this one, eliminate y squared with that one. Then you get x and y. So you express x in terms of y or y in terms of x. Then you substitute back again in one of the equations. When you solve, you get a quadratic. If you get one answer, the quadratic got the quadratic attained gives one root, which is repeated, then the circles do just touch. Then sometimes if they don't ask you whether the circles touch, they can ask you to show or to prove that the circles intersect. If they are to intersect, then what is going to happen is they are going to have what we call a common chord. There is this chord which is going to arise here. They will have what they call a common chord. And even you use the same procedure like the one before here when the circles touch and sort of simultaneously, then in that case, you'll get two different points, A and what? And B. Those 2 points would mean the circles have touched. Their common chord is just a matter of subtracting equation 1 of one circle minus equation 2 is equal to the equation of the common chord. I don't know that people have landed on some of those examples, but if you do, you will post them in the group so that I can be in position to handle some of your concerns on circles. I'm sorry today I don't have examples on these. I'm just commenting on them so that people can go through them. Then the last bit I want to mention here is the bit of orthogonality on intersecting circles. When they tell you circles are orthogonal, what do you put into consideration? When circles are orthogonal, when they intersect, they will have their centers. At their centers, where they meet here at point A, they will meet, their radii will meet at 90. Whether it's down here, their radii, whereby the radius of one will be the tangent of another at that point of intersection. So at that instant, this one has R1, this one can have radius 2. So if they meet at 90, then C1, C2 as the distance squared would be equal to R1 squared plus R2 squared. If this is satisfied, then we say this is called the orthogonality condition. So that's what you use to prove orthogonality. So you get the distance between the two radii, big R. Big R is equal to the square of small r1 plus the square of small r2. Then the circles are orthogonal. Okay, so basically that's about the circle. All right. That's about the circle. Okay, then. After the circle, we are going to the other advanced items in the conic section, which I also want to put. These ones, at least I have examples already displayed here. I will use some of them, but I'm going to mention their general comments of what it takes to have some of the items. And as you see, if you want these images, I can send them, and you have them as well. But before we can talk about anything, when you look at this statement, says the conic section, whereby the conic sections are curves obtained by cutting a right circular cone. If you have a purple, you all know purple. Have you tested a purple? The purple has the shape of a cone, eh? Something like this. That is our cone. If we cut it like this, we shall form an ellipse. Eh? If they have it, you will form a what? A parabola. Someone cuts it from this side. So a cone, you know how a cone looks like. The first conic section it has is a circle. Then when you go on cutting it, you can have a parabola, you can have an ellipse, you can have a rectangular hyperbola, and so on and so forth. But what we want to discuss today, we have finished the circle, which say eccentricity is 0. Then we have what we call a parabola, which has got eccentricity 1. Then we shall have an ellipse, which has eccentricity between 0 and 1. Then this one is off your syllabus, the hyperbola. Instead, you have what we call the rectangular hyperbola. You survived the parabola, the hyperbola. Someone has a chart. Naruwa, I must stop chatting in class. What do you want to record? If you want previous videos, I can give them to you. Yes, please.
Say it's Shamira who was requesting me to record for her, but me I failed to record.
Recording what? The videos?
This work, yeah, she's
I
not
always have them.
attending.
Just ask, I can give you. Or you go to my YouTube channel.
Okay.
You just put in my name on YouTube, you can always find them. Okay. Now the parabola will not take you back to the aspects of how we derive it to bring us the eccentricity with the ratio in which it is coming from. A conic section whose locus of a point moves so that its distance from a fixed point, which is the focus to the line, is equal to this one. No, I will not take that much time. So what I will do, straight away, I'll take you to what the parabola says. For example, we have what we call parabolic equations. The parabolic equations include 1, y squared is equal to 4ax. And this is called a horizontal positive parabola. It's a horizontal positive parabola. This is how it looks like. Looks like this. With the focus here, which is A what? A0. With this as the x-axis. Yeah. No. And y-axis. So this is the positive parabola, which is y squared is equal to 4ax. If you want to talk about the negative parabola, then you say y squared is supposed to be equal to a negative 4ax. This one is the negative. A horizontal negative parabola. This is how I would describe them so that we don't take so much time. How does this look like? This is the y-axis. This is the x-axis. This one takes on a shape like this. And this is called the apex. So this one will have the focus here as negative A0. Okay. Then also we have what we call the vertical parabola. The vertical parabola. The vertical parabola, which is positive, looks like this. Y-axis, it is symmetric about the y-axis. So its apex touches the x-axis. And this one is in the form x squared is equal to 4ay. Then the negative one takes this shape. Negative parabola looks like this. Of course, this one has a, the focus is what? 0a. Those of us who cram, now you're good. This is 0, negative a. This is x-axis, this is y-axis. This is a negative vertical parabola. So those are the shapes I wanted us to review so that we all know that this is how the parabola looks like. Now, if I can advance to the further equations of a parabola, do we have any questions on those shapes? If you want to go and review how they come about, you use this concept and this one. But I know, as per what the syllabus talks about, UNEB can't talk much about that first part. It wants a lot of this knowledge I've talked about. Okay, so let's go for the tangents. We go for the parametric equations of the parabola, which can be defined by a curve. So having confirmed these shapes. Oh, there is one shape I've not mentioned. What if the parabola does not have the apex at the origin? What if y squared is equal to 4ax plus b? Then the parabola will shift. The apex, you investigate when x is 0, y is what? Y is b. Y is plus or minus root b. So it means when y is 0, y is equal to plus or minus b, root b. When y is 0, x is equal to a negative b over 4a. You just use intercepts to check on that. All right? So when you use intercepts to check on that, the curve will shift and move ahead. But as you know, in pure math here in Uganda, we don't mark diagrams. But we use diagrams to guide students to get the right answer. So if you have a wrong diagram, then you'll get no marks. So the same applies. What if you had x squared is equal to 4ay maybe minus c? First of all, it is positive, so it's a U shape. Then when y is 0, x is negative, or negative, x is what? This is impossible. So it's supposed to be like this. So it means x is plus or minus root of c. So if x is plus or minus root of c, if x is plus or minus root of c, nkyali mu kibiina kankubire nga mmaze. Ndi mu class kakubire nga mayiriza. So I'm saying if c is plus or minus, x is c plus or minus c, then this is what is going to happen. X squared will give us plus or minus root of c plus or minus root of c. Then it will come and pass through these two, and it will go like that. Sometimes, it is relevant to have the sketch in your head, or to know what exactly you're supposed to draw. Okay, so with that, let me take you through the general equation of a parabola. So we have heard of the parabola before, whereby if you have a parabola defined by the x-axis and the y-axis, and it is in the shape like this, with a focus S0, then you can have points on the parabola P, which is 80 squared and 280. Then you can have what? P is defined by that on the parabola, which parabola is y squared is equal to 4ax. Then it means x at any one point is 80 what? Squared. Then y is equal to 280. Then we can get the x dt to be equivalent to 2a t. Then we can get dy dt to be equivalent to 2a. When I use chain rule, I can have dy of dx to be equivalent to dy dt times dt dx. Dy dt I've already attained 2a. Then dt dx, this is dx dt, yet this is dt dx. So reciprocate this and get its reciprocal to give us 1 over 280. I can reduce the 280 by division, and I get 1 over t as the gradient function of that parabola at any point. When I get its gradient function, it means I can find the gradient of the tangent. So that becomes the gradient of the what? Of the tangent. So if I want to find the equation of the tangent, what shall I do? I'll suggest y minus 280 out of x minus 80 squared is equal to 1 out of t. On simplifying this, cross multiply, we shall get yt minus 280 squared is equal to x minus 80 squared. So yt minus x, this is 280, okay, minus 80 is going to be equal to 0. Then, if I want to get because the tangent always has what we call the what? The normal, which is at 90. The normal, if the normal has a gradient m1 and the tangent has a gradient m2, when those two gradients are multiplied, you get -1. So m1 times 1 over t is equal to -1. So m1 can be equal to negative t. This becomes the gradient of the normal. While this one is the gradient of the tangent. So when I substitute, what will I have? I will use the same point, y minus 2at out of x minus 8t squared is equal to negative t, giving me negative t of x plus 8t cubed is equal to y minus 2at. When I simplify, I'll realize y plus tx minus 2at minus 8t cubed is equal to 0. Then this becomes the equation of the normal. The other one has become the equation of the what? Of the tangent. Now, when you know those two equations, they can ask any other arbitrary question. Show that the tangents at a point P and a point Q meet at the apex. Show that the tangent at point P and point Q meet at the x-axis. Show that the tangent on this and that. Now, every knowledge you see in Parabolic comes from whatever I've discussed. Like the examples we are going to take a look at. So everything that comes or follows next comes from all those definitions. But at least these are the things one should know on the parabola before you visit a number in the paper. One, a parabola is y squared is equal to 4ax for the horizontal. Then the vertical x squared is equal to 4ay. Then also one should know how to derive or how the equation of the parabola in terms of the tangent looks like and how the equation of the normal looks like. When we know those items, we will be better students in one way or the other. Okay, let me see what we can have here. Now, if you look at this one, look at these examples down here. They are saying find the locus and the directrix of the following parabole. Okay, I did not talk about the directrix. But now, if you have y squared is equal to 16x, yeah? The directrix is that line which passes through the what? Through A, which A is along the focus, which A predicts the focus of the parabola. So, the standard equation of the parabola has a focus, which is A0. And the directrix, which is x plus A, is equal to 0. Now, according to the equation, y squared is 16x. This means you have 4 times 4 times x. Yet the equation of the parabola is in the form 4a what? X. So this can deduce a as being what? 4. So the focus will be s, which is 4, 0. Then the directrix will be x plus 4 is equal to 0. Or x is equal to negative 4. That is how this equation came about. Okay? So that's how we came to get. I was saying, the standard equation of a parabola has a focus A0, which I defined here. It has a directrix, which directrix is used to predict the what? The equation of the parabola. Though I did not take you through the derivation. And the directrix is x plus a. So if you get a, you just have to drop it here and get the directrix. So when I have an equation like y squared is equal to 16x, split it and write it in this form. With a 4, then whatever is in the middle between 4 and x would imply it is the value of a. So according to this equation, a is equal to 4. Okay. So you can have that down. There is this example I want to take a look at here, which is kind of tricky. It's not the common obvious examples you normally see.
Shall wait.
Yeah, it's okay. I'm still waiting. So guys, are we there? Look at example 2. Hey, I've written it poor. It's supposed to be y squared. Starting with example 2, y squared is equal to half times x. But remember, we have to write it in the form of 4x. Now, if you cannot easily get it, just compare the coefficient on x, which is 4a. Compare it with this half. Then you let 4a to be equal to what? Then you will see that A will be equal to 1 out of 8. So if A is equal to 1 out of 8, the equation would have been y squared is equal to 4 times 1 out of 8 of x. Then you can get your focus as 1 out of 8 what? 0. Then you get x is equal to negative 1 out of 8 as your directrix. I don't know that you've seen that. If you have a challenge, you raise it. Are we there? Then for the number 3, for number 3, it requires you to have y squared, for example, plus 4y is equal to x plus 1. Now, this side, how do you simplify it? You use completing squares, and you can say y squared plus 4y plus half the 4, you get 2 squared minus 2 squared is equal to 2x plus 1. So you get y plus 2 squared is equal to 2x plus 5. This 4 goes over with a negative, becomes a 5. So this is in line with this being capital Y, okay? And if this is capital Y, then it means capital Y is x is small y plus 2. Then if you have capital X, this is the same as having this in the form x plus 5 over 2. So capital X can be equal to small x plus 5 over 2. Now, if you want to get the focus, the focus can be got from of course, what we have intended here is to first make the coefficients of x and y be 1. For example, you see y here plus 2, the coefficient there is 1, is equal to x plus 5 over 2. Also that one, the coefficient is 1, okay? So if you want to have, if you want to have what? If you want to find means of getting, we have said we let y be equal to small y plus 2, then capital X to be equal to small x plus 5 over 2. The 5 over 2 has come about as a result of dividing both by 2 here and by 2 this side. If you divide by 2, what is happening? This is what is happening. You will have capital Y squared is equal to 2x plus 5. But if you decide to divide this by 2, yeah, then what shall we have? You'll have another 2 up here. And this would make it be in line with, if you make it be with another 2 here, I make it, because we have to make it in this line. So if there is a half, or so we make it, there is a silent 2 which has come up here. So this silent 2, I equate it to 4a. That means my a is going to be equal to a half. So if my a is a half, then y squared would be equal to 4 over half of the capital X. Then my s will be a half 0. How I've dealt with that is that when I divide this whole thing, this one, by 2, this 2 comes down, not so. But for this 2 to be brought down, I have to introduce another 2 up, so that when I simplify, the 2 cancel. So that 2 makes it be in line with this. So the x is in the brackets connected with this. So that x is this one, which is here, because now it is what I'm calling 2 times capital X. But how does this 2 come about? It comes about because we have equated it to 4a. So I can also stop talking about those 2. Then I advance to the conical, to the chord what? Focal chord.
Sorry, I can't sit down.
You can't sit down, eh? Okay, let me raise it up a little. Have you tried to enlarge it? I will not try it so deep down. So here we are. So we have the condition for the common chord. So for the equation for the focal chord, that equation, that line should be passing through the focus. And it would meet a point P here, which is AP squared to AP. It would meet a point Q here, which is HU squared to A Q. And if the equation of the focal chord is to be determined, then the gradient, this is point P, the grad of PS should be called the gradient of QS. So you get the gradient between Q and S and the gradient between S and P, which is 2AP minus 0 over AP squared minus A. It's going to be the same as, I can as well even use the entire equation. That maybe the gradient of PS is equal to the gradient of PQ. So the gradient of PQ is 2AP minus 2HU over AP squared minus HU squared. So we can simplify 2AP over A into P squared minus 1 is equal to 2A into P minus 2 over A into P squared minus 2 squared. So when I simplify this, A can divide off even this one, even this 2. What do I remain with? P out of P squared minus 1 is equal to P minus 2 out of P minus 2 into P plus Q. This is 1 over P plus Q. So I'll get P squared plus PQ is equal to P squared minus 1. I've cross multiplied this one to this one. Then I can lose the P squared. Finally, PQ is equal to negative 1. This is the condition for the focal chord. They ask you to prove that the line passing through 2 points P and Q is a focal chord of P and Q. Then that is the condition you have to take into consideration. Unless someone has a question on that condition.
I haven't understood.
Pardon?
I haven't understood.
I'm saying you get the gradient from P to S. It is the same gradient from S to Q. Or it's the same gradient from Q to P. So I've considered PQ and PS. But one could have said, even here I can use 2AQ minus 0 over AQ squared minus A. Let me show you when I use these two. We would get 2AP over A into P squared minus 1 is equal to 2AQ out of Q squared minus 1. The 2A would die with this one. Then you'd get PQ squared minus P is equal to P squared Q minus Q. This would give us P Q squared minus P squared Q is equal to P minus Q. When you factor out, you'd get PQ into Q minus P is equal to P minus Q. When you divide the Q minus P on both sides, this is a negative of the downer part. Therefore, still PQ will be equal to negative 1. So it's about looking for the gradient over here and the gradient over there, or the gradient for the entire line. Those three gradients are the same. When you equate them, you can get an equation for the gradient. So we have a question here, which says find the points of intersection of the tangents at the points capital T1 and capital T2 on the parabola y squared is 4ax. So these 2 points have varying points. Capital T1 has at1 small to at1 small t. Capital T2 has at2 small squared to at2. So they're asking us for their points of intersection here, x and y. First and foremost, you need to get the equations of the tangents and then solve them simultaneously. We have already seen that the tangent, gradients of a tangent is 1 over t. So now I want to find the equation of the first one. I'll have y minus 2at1 over x minus 81 squared is equal to 1 out of t1, giving me y t1 minus 2at1 cubed is equal to x minus a t1 squared. Oh, this is squared, giving us y t1 minus x minus 81 is equal to 0 squared. This would be equation 1 for the first one. Consequently, for the second one, I can just deduce it from here. It would be y of t2 minus x minus 82 squared is equal to 0. And this would be the second equation for the second point. Then when we subtract Roman 1 minus Roman 2, we would eliminate the x and get y into t1 minus t2 plus 82 squared minus 81 squared is 0. Then we shall get y is equal to a into t1 squared minus t2 squared divided by t1 minus t2, which simplifies to a of T1 plus T2. That is the first part. You get Y. Since we have got Y, I can substitute this very Y. I have got any of the two. Let me put it in Roman 1. I will have A into T1 plus T2 times T1 minus X minus 8T1 squared is equal to 0. So we would make X the subject. When X crosses over the other side, we shall remain with 8T1 squared plus 8T1 T2 minus 8T1 squared. And this can be reduced by subtraction. So X becomes A T1 T2. Then the coordinates would become A T1 T2 and A into T1 plus T2. And that would be your answer for capital T. Unless if someone has a question on that. Okay, for this number it says, prove that the tangents at the ends of the focal chord are perpendicular. You have to prove that this tangent, which is coming from the focal chord here, and this one, which is coming from the focal chord there, they meet here at 90 degrees. But one of the principles there is that they meet at the directrix, which directrix is equal to negative A. And remember, when they meet, we shall have A, T1, T2, and A of T1 plus T2. That's the point where they meet, as we have seen earlier. Now remember, the gradient of this one is 1 out of T1. The gradient of this one is 1 out of T2. The product of the two gradients, 1 out of T1 and 1 out of T2, should be equal to negative 1. This should be proving that T1, T2 should be equal to negative 1. So this is what you should prove. When you prove that T1 and T2 are equal to negative 1, then it would imply that the gradients of these are actually equal to negative 1. Those small t's, when you multiply them, they're equal to negative 1. So get the gradient of this point, capital T, to capital T1. You know capital T1 has 8T1 squared to 8T1. Then capital T2 has 8T2 squared to 8T2. So gradient capital T1 will give me 280T1 minus 280T2. Sorry, minus A over T2 plus T1 over 8T1 squared minus 8T1 T2. This will simplify to 280T1 minus 8T2 minus 8T1, all is over 8T1 into T1 minus T2. Up we shall get A into T2, T1 minus T2. Down we shall get 8T1 into T1 minus T2. These two die. This gradient is 1 over T1. Then can we get the gradient of the second one? So for the second one, what is going to happen is going to be for the second one, you see what is going to happen. We are dealing with gradients of capital T and T2. This will give me A of T1 plus T2 minus 280T2 all is over 81 T2 minus 80T2 squared. This will take me to 81 plus 82 minus 282 over A into T2 into T1 minus T2. This will take me to A into T1 minus T2. Over 8T2 into T1 minus T2. One should be a negative. Which one should have been a negative? I used to 81 minus. I reduce this one and I reduce this, I get 1 over T2. Okay, it's okay. So this is the gradient of the second one. So when I multiply the gradient of the first one times the gradient of the second one, the answer should give me -1 for them to be perpendicular. So therefore 1 over T1, T2 should give me -1. Therefore T1 times T2 is actually -1. Hence the condition for the tangents of the focal chord to meet at right what? Right angles. Okay, we can download that. If no questions. I think you can have like one more. Oh, one more that I talk about the rectus rectum. Next time we shall talk about the ellipse. I think we should look for some time over on Saturday and Sunday, so that this week we get done with the conics. Here, a number is trying to account for orthogonality. I don't know whether I should do it or not. Are you done downloading that? Guys, are we done downloading that?
Not yet.
Okay. this question says, find the equation of the tangent of the parabola from the point 16a up to 16a, 17a. So if this is your parabola, and this is the tangent, then it's coming from a point 16a, 17a. And from there, you need to just find one. You should know the gradient of the tangent. Remember, the parabola is 8t squared to 8t. The tangent is, the gradient is 1 over t. So y minus the point of the, which passes through the line, which is equal to 17a over x minus 16a is equal to 1 over t. And the answer will be yt minus 17at is equal to x minus 16a. That is the answer. That is how far you can handle such a problem. Okay, finalize that. We look at the rectus rectum, and we conclude the parabola. It is not so easy to finish the whole of this section in 1 hour or 2 hours, even if you're just reviewing, because it's quite wide. But at least what you should know, you should get one conic section. At least try out one.
Teacher, let's continue.
Okay. The rectus rectum. The rectus rectum this rectus rectum predicts that the length of the focal chord should be a constant. But no matter the direction of how you've designed it, the length of the focal chord should be what? Constant. So if you have And this is going to be, this is the focal chord. The focus is S0. Then this point P up here will be A to A. And this one will be A negative 2A. Point P2 is point P1, whereby this is the x-axis, this is the y-axis. So the Rectus rectum predicts that that line intersects the parabola at 2 points. This is what they call the Rectus rectum. It intersects the parabola at 2 points, and at those 2 points, those points are A, 2A, and A, negative 2A. Because this is assumed, for example, to be a straight vertical line, and whereby Y is supposed to be equal to plus or minus 2A. And how does this come about? It comes about when you have X, if X is equal to A at that instant, because at this line, if this line is vertical like this, then X is A and X is A also down here. So from Y squared is equal to 4AX. When X is A, you'll get Y squared is equal to 4A squared. So Y would be equal to plus or minus 2A. That's why we have a 2A up here and a negative 2A down there. So that's how it comes about. So we have a question here. Find the focus comma, directrix, and length of the Rectus rectum. Of Y is equal to X squared, sorry, 2X squared plus 3X minus 5. Now, because you see it is X which is quadratic in this form, you can create a coefficient 1 on X squared plus 3 over 2X minus 5 over 2. So that we complete squares. We have Y over 2 is equal to X squared plus 3 over 2X plus, when you have this, you get 3 over 4. So you get 3 over 4 squared minus 3 over 4 squared minus 5 over 2. This will give us Y over 2 is equal to X plus 3 over 4 squared minus 9 over 16 minus 5 over 2. So Y over 2 would give us X plus 3 over 4 squared minus 9 minus 2 goes in 16 how many times? 8. So minus 40 over 16, giving us Y over 2 is X plus 3 over 4 squared minus 49 out of 16. So when you make X the subject, you'll have X plus 3 over 4 is equal to Y over 2 plus 49 over 16. Then you use the other principle I gave you earlier. You assume this is equal to capital X. Then you can assume this is equal to capital Y. Okay. Then you would get to see that if this is capital X squared, you can let capital X be equal to small x plus 3 over 4. Then we shall have capital X squared is equal to, then we can let this one be equal to, if you factorize this out, this becomes what? You have 8y plus 49 over 16. But if I want to create a 4 here, then I will have it coming from, I will have 1 out of 16 into 8y into 8y plus what? Plus 49. So that this will give me actually, when you get the square root of this, you'll see that you get plus or minus 4. So this will give me x squared of 4 of 1 out of 8 of y. Whereby if I divide 4 by 8, it goes back to a half, which a half was the silent coefficient on y. So when we get that coefficient, my a becomes 1 out of 8. So the focus becomes 1 out of 8, 0. The directrix becomes x is equal to negative 1 out of 8. Then we are left with the length of the rectus rectum. The length of the rectus rectum is going to be got from, the length of the rectus rectum depends on this distance from here up to here. But this distance from P up to S is the same as from S up to P2. So length is equal to P1S plus P2S, which is the same as 2PS, or twice the distance from there, which is always equal to 4A. This is a constant. It is always equal to 4A. So if it is equal to 4A, we have already seen the A is 1 out of what? 8. So the length of the rectus rectum is going to be a half. And that will be the answer. So always the length of the rectus rectum, length of the rectus rectum is always equal to twice of A plus twice of the other A, which gives us 4A. So it is this that predicts the rectus rectum by substituting in the attained value of A. Okay, people are tired. They have less responses. Finalize that, then we can close off. Let me also pray as you finish. I guess everyone is done, and have a good night. Hey, Jauto,